it looks like this in this exercise they're asking us to do many things, and I encourage you to pause this video and try to do it on your own first and then see maybe how I tackle the same exact thing. So the first thing they're saying is draw a 60-degree angle in standard position together with a unit circle. Use the triangle below, so this triangle right over here, to find the x and y coordinates of the point of intersection of the terminal side and the circle. So let me draw a unit circle here. So that is my y-axis, and then this could be my x-axis. And then I'm going to draw a unit circle, which is a circle of radius 1. So I'm going to do my best to draw. It's obviously hard to freehand draw a circle, but I have a little easier time when I draw it as a dotted line. I can later make it undotted. Okay, so that's pretty close. My best attempt at freehand drawing a unit circle. So there you go. Fill in the dots. Now that I don't need it to be, I want it to be a solid line. So that's my best attempt. Fair enough. So I've drawn the unit circle. Unit circle. It has radius 1, so this point right over here is going to be the point 1, 0. The x-coordinate is 1. The y-coordinate is 0. This point right over here, the y-coordinate is 1. The x-coordinate is 0, so that's the point 0, 1. And then this right over here is the point -1, 0. And this point right over here is 0 x-coordinate and a -1 y-coordinate. There you go. So those are those 3 points, or those 4 points right over there. So that is my unit circle. And now they say draw a 60-degree angle in standard position together with the unit circle. So standard position, you'd draw a ray. It's centered at the origin. It's along the positive x-axis. That's your initial side of your angle. And then since we're going at positive 60 degrees, we'll go in a counterclockwise direction. So we're going positive 60 degrees, counterclockwise direction. And so your terminal side will be a ray that looks something like that. So that's our 60-degree angle in standard position. Use the triangle below, so that's this triangle, to find the x and y coordinates of the point of intersection of the terminal side and the circle. So it sounds very complex, but all they're saying is, what are the x and y coordinates of that point right over there? So what is the x coordinate and what is the y coordinate? And I'll give you a little bit of a hint here. We can construct a right triangle by taking a line from that point and going straight down. Since it went straight down, we know that this is a 90-degree angle. We also know if this is a 60-degree angle right over here, so this is a 60-degree angle, this is a 90-degree angle, we know that all the angles of the triangle have to add up to 180 degrees, so we know that this up here is going to be a 30-degree angle. So using that information, and this triangle right over here, and what we know about similar triangles, can we now figure out what x and y are going to be? Well, let's think about it. Let's think about it a little bit. So what our x-coordinate of this? That's just the distance that we have to go along the x-axis right over here. This is the x, and then we would go y up that much. So this distance right over here, essentially the bottom of this 30, 60, 90 triangle, this length is going to be equal to our x-coordinate. And then this height right over here, the height of this triangle, the length of this side, that's going to be equal to our y-coordinate. That's going to be equal to our y-coordinate. So if we just figure out the lengths of these sides, then we know what the x and y coordinates are going to be. And we also know that these are similar triangles. You have a 60-degree angle here. You have a 60-degree angle here. You have a 30-degree angle up here. You have a 30-degree angle up here. You have a 90-degree angle over here. You have a 90-degree angle over here. So all of the angles are the same. These are similar triangles, which tells you the ratios of corresponding sides are going to be the same. Well, let's think about the ratios of the corresponding sides. Well, what sides do we know on this triangle right over here? Here they gave us all of the sides. What sides do we know here? Well, we knew that this was a unit circle. So what is the distance between our origin and this intersection point? So what is the length essentially of the hypotenuse of this right triangle? Well, the hypotenuse is a radius of the unit circle. A unit circle is a circle that has radius 1. So the hypotenuse here has radius 1. And so hopefully we can now use this information and the ratio, and knowing that the ratio of the corresponding sides are going to be the same, to come up with what x and y are. So one thing we could say is the ratio of the short side of this triangle to the long side should be the same as the ratio of the short side of this triangle to the long side, or the ratio of the side opposite the 30-degree angle to the hypotenuse should be the same as the ratio of the side opposite the 30-degree angle to the hypotenuse. So we could say the ratio of 1 to 2, the ratio of 1 to 2 would be the same as the ratio of x to 1 to the hypotenuse. Or we could this immediately gets solved because x divided by 1 is just equal to x. Or we get x is equal to 1/2. X is equal to 1/2. Well, let's use that same logic again. The ratio of this side opposite the 60-degree side to the hypotenuse, so square root of 3 to the hypotenuse, should be the same as the ratio of the side opposite the 60-degree angle, which in this case is y, to this hypotenuse, to 1. Well, once again, this is essentially y divided by 1 is just y. So we get y is equal to square root of 3 over 2. So we now know the x and y coordinates. This we can rewrite as 1/2 comma square root of 3 over 2. Square root of 3 over 2. Now, the last part, they ask us to confirm that the x-coordinate is equal to cosine of 60 degrees. Let me do that in a different color. Confirm that the x-coordinate is equal to cosine of 60 degrees. Well, let's take out our SOHCAHTOA again, just to remember what sine, cosine, and tangent definitions are. So, let me do this in a different color. SOHCAHTOA. So what's the cosine of 60 degrees going to be equal to? So the cosine of this angle. So the cosine of 60 degrees is going to be equal to the adjacent over the hypotenuse. It's going to be equal to x over the hypotenuse. It's going to be equal to x over the hypotenuse, which is just 1. This is a unit circle. So x is going to be equal to the cosine of 60 degrees. Our x-coordinate is the same thing as the cosine of 60 degrees. And we already figured out that x is equal to 1/2. So it's equal to 1/2. So that all checks out. And we can do the same thing for the sine. Well, let's make sure that the y-coordinate is equal to sine of 60 degrees. So sine of 60 degrees, based on our definition of these trig functions, is equal to the opposite over the hypotenuse. So it's equal to, the opposite is our y-coordinate. The length here is the same as our y-coordinate. So it's equal to y over our hypotenuse. Well, that's definitely equal to y, which we already got with square root of 3 over 2, which is equal to square root of 3 over 2. So that checks out. And that y over x is equal to tangent of 60 degrees. Well, tangent is opposite over adjacent. So let me write it over here, running out of real estate. Tangent of 60 degrees. TOA tells us it's opposite over adjacent. The opposite side is y. The adjacent side is x. So that also works out.